In 1965, archaeologists excavating a site in Ukraine uncovered something that shouldn't have existed. The remains of a 15,000-year-old house with central heating, sophisticated ventilation, and insulation properties that rival modern Arctic research stations. The builders had no metal tools, no written plans, and no formal engineering training. Yet they created winter shelters so effective that entire families lived comfortably through 6-month winters that would kill a modern human in hours. How did they do it? The answer lies in a revolutionary principle that turned humanity's greatest enemy into its most powerful ally. The bitter wind howls across the frozen landscape as snow begins to fall heavily on the Eurasian steppe. Temperatures plummet to negative 40 degrees Fahrenheit, transforming the world into a crystalline wasteland where even breathing becomes an act of survival. For the next 6 months, this land will be locked in winter's merciless grip. A modern human, even with our advanced gear and technology, would barely last hours in these conditions. Yet remarkably, 30,000 years ago, entire families not only survived but thrived through winters like this, raising children and creating some of humanity's most sophisticated art in these seemingly impossible conditions. They had no permanent walls, no central heating, and no insulated buildings as we know today. But what they possessed was perhaps even more valuable: an intimate understanding of their environment and an ingenious approach to survival that would impress even modern Arctic engineers. The story of their survival is not just about endurance. It's a testament to human ingenuity and adaptation that would shape the course of our species. The popular image of Ice Age humans often depicts them as primitive cave dwellers, huddling around fires in dark caverns to escape winter's fury. But recent archaeological evidence reveals a far more sophisticated reality. Our Paleolithic ancestors developed winter survival technologies so effective that they enabled human expansion into the most challenging environments on Earth. From the Mammoth Bone Houses of Ukraine to the snow caves of Siberia, these ancient engineers created winter shelters that utilized principles we're only beginning to fully appreciate today. The breakthrough came with a simple but revolutionary realization. When nature tries to kill you, you make nature work for you instead. This principle guided every aspect of Paleolithic winter shelter design, from material selection to construction techniques to heating systems. Rather than fighting against snow, wind, and cold, our ancestors learned to harness these forces for protection, turning potential killers into life-saving allies. The earliest evidence of this sophisticated approach comes from Kostroma in Russia, dating back an astonishing 800,000 years ago. Here, archaeologists discovered what may be humanity's first engineered cold weather housing, a discovery that revolutionized our understanding of early human capabilities. These early Arctic pioneers had excavated circular depressions up to 8 feet deep and 12 feet across, creating the foundations for semi-subterranean winter homes. The engineering principles behind these underground shelters were remarkably sophisticated, demonstrating an understanding of thermodynamics that wouldn't be formally documented for millennia. By digging below the frost line, early humans accessed the Earth's natural insulation properties. At depths of 6 to 8 feet, soil temperatures remain relatively stable year-round, typically 20 to 30 degrees warmer than surface air during winter. Analysis of tool marks and soil composition reveals this wasn't accidental. These depths were deliberately chosen for maximum thermal efficiency. Recent experimental archaeology has shown that these simple-looking pit houses could maintain temperatures above freezing even when outside temperatures dropped to lethal levels. The combination of earth insulation, carefully planned ventilation, and strategic use of fire created microclimates that allowed families to not just survive, but maintain rich social and cultural lives throughout the winter months. But perhaps most remarkably, these early settlements weren't just about survival. They were innovation hubs where some of humanity's most important technological advances were developed and refined. The challenging conditions of Ice Age winters pushed our ancestors to develop sophisticated tools and techniques that would later prove crucial to human expansion across the globe. From advanced insulation methods to complex social organization, these winter adaptations became the foundation for human civilization as we know it. The real breakthrough in winter survival came with the development of composite insulation systems. At Dolní Věstonice in the Czech Republic, dating to 26,000 years ago, archaeologists uncovered evidence of winter shelters that used layered insulation techniques so advanced they wouldn't be seen again until modern times. The walls of these structures incorporated multiple material layers, each serving a specific thermal function, an engineering feat that would make modern architects proud. The most extraordinary examples of Paleolithic engineering prowess come from the Mammoth Bone Houses of Ukraine and Russia. At sites like Mezhirich and Kostenki, dating between 25,000 and 15,000 years ago, archaeologists have uncovered structures that represent the pinnacle of prehistoric architectural achievement. These weren't simple shelters thrown together for basic survival. They were carefully engineered buildings that combined sophisticated understanding of structural mechanics, thermal efficiency, and social design. The construction of these mammoth bone houses began with meticulous planning. Builders first excavated circular or oval depressions approximately 12 to 16 feet in diameter, sized precisely to accommodate extended families of 8 to 12 individuals. The excavated earth wasn't discarded, but strategically piled around the perimeter to create berms that provided crucial wind protection and thermal mass. Recent archaeological analysis has revealed that these foundation dimensions weren't arbitrary. They represented the optimal balance between heat retention and living space. The true genius of these structures lay in their framework design. Builders used the massive bones of woolly mammoths, creating an architectural system that took advantage of the natural strength and thermal properties of these materials. Mammoth skulls, some weighing over 200 pounds, served as foundation blocks, placed with remarkable precision to distribute the structural load evenly. The curved tusks and long bones were ingeniously arranged to create dome-shaped frameworks that could withstand the immense weight of winter snow and fierce Arctic winds. What's particularly fascinating is the evidence of sophisticated material selection and preparation. Radiocarbon dating of the bones used in construction has revealed that many came from mammoths that had died long before the shelters were built. This indicates that Paleolithic builders weren't just opportunistically using whatever materials they found, they were systematically collecting and curating construction materials from boneyards, possibly maintaining knowledge of these resource locations across generations. The covering system for these structures revealed extraordinary innovation in textile technology that wouldn't be seen again for millennia. Analysis of preserved organic materials shows that builders created composite wall systems using multiple types of animal hides, each chosen for specific properties. The outer layer consisted of thick mammoth hides, methodically sewn together with sinew thread using bone needles, a task requiring immense skill and patience. Beneath this weather-resistant shell, layers of smaller animal pelts from wolves, foxes, and Arctic hares created a sophisticated insulation system that trapped air in multiple layers, much like modern high-tech outdoor gear. Perhaps most impressive was the anchoring system used to secure these materials. Archaeological evidence from several sites has revealed an ingenious system of bone toggles and hydrobes, natural fiber ropes treated with animal fats for weather resistance. This allowed the covering to be tensioned precisely, preventing wind infiltration while maintaining the flexibility needed to withstand storms. The engineering principles behind these fastening systems are so effective that similar approaches are still used in modern Arctic temporary structures. Recent experimental archaeology has demonstrated just how sophisticated these structures were. Modern reconstructions have shown that a properly built Mammoth Bone House could maintain interior temperatures 40 to 50 degrees warmer than the outside air, using only modest fires. This thermal efficiency rivals modern Arctic shelters, equipped with industrial insulation materials. The key lay in the combined effects of the semi-subterranean foundation, the thermal mass of the mammoth bones, the multi-layer insulation system, and the aerodynamic dome shape that minimized wind resistance while shedding snow effectively. These weren't just shelters, they were complete living systems that represented the culmination of generations of accumulated knowledge about survival in extreme environments. The construction of each Mammoth Bone House required the coordinated effort of an entire community, with different individuals contributing specialized skills in bone preparation, structural assembly, hide working, and insulation installation. This cooperative construction process itself became a crucial part of community bonding and knowledge transmission, ensuring that vital survival technologies were preserved and passed down through generations. Life inside these Paleolithic winter shelters was far more sophisticated than previously imagined. Archaeological evidence reveals an intricately organized living space that balanced practical needs with social and psychological well-being. The interior layout of these structures demonstrates a remarkable understanding of both thermal efficiency and human behavior, with every aspect carefully planned to support survival through the harsh winter months. Heating these large winter shelters required sophisticated fire management techniques that went far beyond simply maintaining a central hearth. Archaeological evidence from multiple sites reveals complex multi-hearth systems designed to maximize heat distribution while minimizing fuel consumption. The primary hearth, typically located in the center of the structure, provided the main heat source, while smaller satellite heating stations were strategically placed around the perimeter, creating specialized warm zones for various activities. The fuel management systems were equally impressive, especially given the challenges of treeless steppe environments where wood was scarce. Paleolithic peoples developed sophisticated techniques for processing and using alternative fuels, including mammoth dung, dried grasses, and bone. Chemical analysis of hearth residues has revealed that these materials weren't simply burned as found, they were carefully processed and combined to optimize burn efficiency and heat output. Some sites show evidence of fuel storage areas where materials were kept dry and readily accessible. Perhaps the most ingenious aspect of these dwellings was their ventilation system, a feature that modern Arctic engineers recognize as crucial for winter survival. Without proper airflow, moisture from breathing and cooking can create devastating condensation problems that make shelters uninhabitable. Archaeological evidence shows that Paleolithic builders solved this through carefully designed airflow systems. Small openings near ground level allowed fresh air to enter, while larger vents near the top permitted warm, moisture-laden air to escape. The positioning of these openings created natural convection currents that maintained air quality while preserving heat. Some sites even reveal evidence of adjustable ventilation controls, bone and hide flaps that could be manipulated to regulate airflow based on weather conditions. The social organization within these shelters provides fascinating insights into Paleolithic family life. The interior space was carefully divided into specialized zones, each serving specific functions while maintaining the thermal efficiency of the overall structure. Sleeping areas were arranged around the central hearth, with the warmest spots reserved for the most vulnerable members, infants and elderly. Tool-making areas were positioned near secondary hearths, where good light and steady heat were available for detailed work. These activity zones weren't just practical arrangements, they reinforced social bonds and facilitated knowledge transmission between generations. Food storage within winter shelters represented another remarkable innovation. In permafrost regions, Paleolithic peoples developed sophisticated techniques for using natural freezing as a preservation method. Archaeological evidence reveals the presence of underground storage chambers connected to winter shelters by short tunnels. Analysis of these storage areas shows careful organization, with different types of food stored at varying depths to optimize preservation. The psychological aspects of winter shelter design reveal a sophisticated understanding of human needs during long periods of confinement. Archaeological evidence suggests that these structures included specialized areas for artistic and social activities, spaces where people could gather to create, share stories, and maintain cultural practices during the long winter months. The famous Venus figurines and other portable art objects found at many sites were often discovered in contexts suggesting they were created and used within these winter dwellings, indicating that artistic expression was an integral part of a winter survival strategy. This sophisticated organization of living space wasn't just about physical survival. It created a sustainable winter lifestyle that supported the transmission of cultural knowledge and technological innovation. The evidence suggests that these shelters weren't places of mere endurance, but were actually centers of cultural development, where many of the technological and artistic innovations of the Upper Paleolithic period were developed and refined. The construction timeline for these remarkable winter shelters reveals sophisticated planning abilities that challenge our understanding of Paleolithic societies. Experimental archaeology has demonstrated that building a Mammoth Bone House required 2 to 3 weeks of intensive work by a group of 8 to 10 adults. This wasn't just physical labor, it was a complex project requiring careful coordination and precise timing. Construction had to begin well before winter weather made outdoor work impossible, yet late enough that essential materials would be preserved through the coming cold season. The maintenance of winter shelters was an ongoing process that demonstrated remarkable engineering foresight. Archaeological evidence shows that occupants regularly repaired and upgraded their structures as winter progressed. Broken bones were systematically replaced, damaged hide coverings were expertly patched, and insulation materials were refreshed as needed. This wasn't simply reactive maintenance, it was proactive engineering that improved shelter performance over time, incorporating lessons learned from each winter's experience. Regional variations in winter shelter design reflect sophisticated local adaptations to specific environmental challenges. Arctic coastal peoples developed techniques for building on permafrost, while continental steppe dwellers perfected methods for dealing with extreme wind exposure. Mountain peoples created avalanche-resistant designs, while forest edge inhabitants learned to integrate natural windbreaks into their shelter systems. Each variation represented generations of accumulated knowledge about local conditions, materials, and survival requirements. The impact of these winter survival technologies on human evolution and expansion cannot be overstated. The ability to survive harsh winters allowed early humans to colonize vast regions of northern Eurasia that would otherwise have been uninhabitable. This expansion brought access to new resources and hunting grounds, supporting larger populations and accelerating cultural development. Many of the innovations developed for winter shelter construction found applications in other areas of Paleolithic technology. Composite material techniques were adapted for clothing, tool handles, and hunting equipment. Insulation principles were applied to food storage and protective gear. The knowledge required to build and maintain effective winter shelters was extensive and had to be transmitted across generations with perfect accuracy. Mistakes could be fatal. This need for precise knowledge transmission may have contributed to the development of complex teaching methods and cultural practices that ensured survival information was preserved and passed down. The sophistication of these teaching systems is evident in the consistency of construction techniques across vast geographical areas and time periods. The abandonment of these sophisticated winter shelter technologies following the end of the Ice Ages represents one of the great technological losses in human history. As climates warmed and forests expanded, the need for extreme cold weather shelters diminished. The knowledge was gradually lost, surviving only in a few Arctic regions where environmental conditions remain challenging. Yet the principles these ancient engineers discovered continue to influence modern cold weather construction. Today, military Arctic training programs teach shelter building methods directly derived from archaeological reconstructions of Paleolithic designs. Disaster relief organizations have adapted these ancient techniques for emergency shelter construction in extreme environments. The thermal engineering principles discovered by our Ice Age ancestors remain relevant for modern sustainable architecture, proving that sometimes the most effective solutions are those tested by millennia of survival challenges. The story of Paleolithic winter survival stands as a testament to human adaptability and engineering innovation. Faced with environmental conditions that should have been impossible to survive, our ancestors didn't retreat, they innovated. When we consider the sophisticated thermal engineering, the complex material processing, the precise construction techniques, and the detailed environmental knowledge required to build these winter shelters, we see not primitive cave dwellers, but accomplished Arctic engineers whose innovations laid the groundwork for all subsequent cold weather technologies. Their legacy lives on, not just in the archaeological record, but in the fundamental human capacity to overcome environmental challenges through ingenuity and cooperation. The next time you adjust your thermostat or check your home's insulation, remember that the principles you're relying on were first developed by families living through Ice Age winters with nothing but stone tools and natural materials. Their achievement remains one of humanity's greatest testimonies to the power of innovation and adaptation.